Oh, what's up everyone? So today I'm going to show you how to implement a deep neural network, and this is quite a bit of basic tutorial, not something really advanced, but I think you'll guys enjoy it, especially if you're a first timer like learning these things new, then this is going to be a very good tutorial for you. So at first, to begin with, I'm gonna need some really common libraries that you all are aware of. So first, I'm gonna need NumPy for array manipulation. Let's import numpy as np, and then I'm going to need os for file manipulation of Sora and also working with the directories or joining paths and everything. So and then I'm going to need also import OpenCV. So I'm going to need OpenCV. So if you guys don't have like NumPy, just pip install NumPy. And in case if you don't have OpenCV, just pip install OpenCV. And then I think I'm going to also need TQDM. So TQDM is a package that is used for progress bars with Python. So it works in Linux, Windows, and many other environments, and also friendly with Jupyter Notebook and also IPython. So from TQDM, import TQDM. So in this data set, I think I'm gonna work with data. I'm gonna work with a data set of okay, so a concrete data set that is put in the drive, that Google Drive that I'll be using here. So it's kind of like a concrete image data set that contains like cracked images and non-cracked images of the concretes. So the work is to perform a two-class classification using neural networks. So there will be negative images and there will be positive images of here. So where negative images, I think it will have no crack, and the positive images, it will have cracks. So let's go on. So here is the drive. I think if I go for it, here is the concrete data. So negative and the positive. So I'm just going to copy the path of the concrete data and make a data directory. Data dir is equal to, so this is going to be my data directory, and there are two categories for us. So categories is equal to, as you can see, negative and positive. Negative, and then positive. And now I think we're going to make an image array with the images in the directory. So to do that, we're going to need the OS here. So for category in categories, so we're going to need path equals to os dot path dot join data dir comma category. So what this basically does is like it creates a path to the negative and the positive images that we have in our concrete data files that is going to be used as a data set of ours. So after that, for image in os dot list dir, path. So we are going to iterate over each image our negative and positive classes. So image array equals, we need OpenCV here, CV2. I'm sorry, I got distracted because I received a call in Facebook. I had to cut it down. CV2 dot I am red underscore grayscale. So we're going to convert this directory to array here, and then let's see some of the images. T dot I'm sure CMap is equal to gray, and then VLT dot show. So I don't want to show all the images together. That's going to be lengthy and like it will cover the whole screen. So let's put break to our loops and see at least one sample. Let's run the code and hope we don't get any errors. No, the code is perfectly done. So as you can see, this is a sample image from the dataset of ours. And let's see the image shape. So let's print image array dot shape. Yeah, so in many cases you can figure it out like that. The image shapes, it can be like different. So I think it's possible for us to resize the images, and let's do that. Let's declare a variable image size equals 100, and then new array is equal to cv2 dot resize our image array, comma, I don't want to write the whole variable again, I'll just copy image size, comma, img size. So in this way, like I can resize the image array to a new array, and then let's plot see. So you might ask, like, why am I working with the grayscale images? Is because like it takes really less amount of computation time, and also like the color of these images, it doesn't have much impact in terms of classifying the images. For example, if you're classifying a crocodile with a dog, then it's necessary that we specify the color, because the color of the crocodile and the dog is certainly going to be different, and it can be a criteria that can be used for classifying images. But in this case, the color doesn't have much impact. So our main target is to use uh, uh, our main target is to make the computation process for the neural networks easier. So we're going to avoid these three color channels and use only grayscale. So let's create our training data. So for us, we're gonna create our training data. So training data, and then define create training data. For category in categories. So what I'm going to do is like I'm going to do the similar work that I have done here. So we need to join our path. So I'm not going to write the whole source code again. So path is equals to os.path of join true and category, and then I'm going to need a different variable class name. Class name is equals to categories dot index category. So this is kind of like I mean, it will get the classification 0 or 1. For example, 0 is equal to negative or 1 is equal to positive, this way. And then we're going to need another loop. So do I have the similar kind of lines here? No. Okay, let's write the code then. For image, for IMG in TQDM, os.list dir path. So I'm going to use try here. Like I'm going to put the next piece of code in a try block, and after that, if there is an exception, you can throw it. It can be like, for example, in this case, I know that the dataset, like the images that I have in my folders as dataset, like there are no broken files or anything else. So it can like encounter a dataset where they might have some problematic things like a broken data or anything. So in that case, you might like to throw the exception, like for example, any normal exception or OS error, anything that you want to. So let's put it in a try block here. Try img underscore array is equal to, so I think I have the line here, cv2.inBreadPath, because writing the same line again and again is kind of tedious, so I'm just going to copy that here. And then the new array, I think I have this line here, new array is equal to cv2.resize image array image size. So I'm going to put it here, and then I'm going to append the data. So training data dot append the new array that I have created with the resized images. New array and class num. So I created the variable here as class num. I'm gonna put that in here. And in case if there is an exception, then you can throw it. Except exception as e. I think I'm just gonna pass, and then finally create training data. So I think this piece of code will help us to create our training data. So I hope there isn't any mistake. Let's run it and see if it works. Invalid syntax. Where? For category in categories. Where? For category in categories. Categories. Invalid. Oh, okay. So I'm sorry. This is my classic mistake. What I always do is that I forget to put the semicolon here. I'm sorry, the colon here for the loop, because like in many cases I have to work with different programming languages, like sometimes MATLAB and sometimes Python, sometimes Java. So I forgot this. Sorry. So since we have used TQDM, you can see that nice bars here. So we are done creating our training data. So like this training data here, I think we need to shuffle it, because now it's like all negative images, and after that all the positive images. This is not, I think, a good way that the neural network should learn. So I think what I'm going to do is I'm going to import random so that I can shuffle my data. Random dot shuffle. Shuffle what? Our training data. Training data. So yeah, it has shuffled. To be sure that if it has really shuffled my data or not, let's check it out. For sample in training data, print sample 1. Okay. See, it's shuffled. And then I think we need to create our like X and Y level. X is kind of like our data, and then Y is used for our label. So let's do that. So here I'm not going to like follow the traditional methods like xtrain or ytrain, xtest, ytest. So let's try in a different way. So y is equal to and then for features, label in training data. I'm not gonna do the same mistake again. X dot append what? The features. And y dot append what? The labels. And the other thing is like that we need to reshape it, like kind of as a numpy array. Let's do that. If we don't do that, we cannot use it in the neural network. It's going to show error. np.array x, and we also have to reshape -1 underscore size and for y we are just going to convert it as numpy array np.array and then y. Is it done? I think so. So let's try to print and see if we can get something. Just to be sure, print is a great debugger. I always believe that. I think it's okay. It should be okay. So let's check the code again for features, label, entering data, x happen, y happen, input array, reshape, size, y array. Okay, let's get into the next piece of code. I think it's not a good idea to do all the resizing, reshaping again and again. So, and also the neural network is not kind of like a fixed method, like we already know that how many layers or how many things that we have to use. It may change depending on the data, design, and our need. So we don't want to do like, we don't want to reshape and fix our data again and again. So we're gonna, to solve this problem, we're gonna use the pickle. So import pickle. Pickle underscore out is equal to open x dot pickle right back. And then you're gonna dump it. Pickle dot dump x comma pickle underscore out. Pickle underscore out dot close. And we're gonna do the same thing for our y variable. So it's like y dot pickle and then y pickle out and pickle out dot close. Let's run it. And I think you can see like there are the files like x dot pickle and y dot pickle here already, so we can reuse it whenever we want to. And now, since our data is ready, so next get into the second part where we use neural network. So we're gonna need TensorFlow for this. Import TensorFlow as TF, and from TensorFlow dot keras dot datasets Okay, sorry, I'm sorry. Actually, we're using our very own data set. I don't think that, like, how can I say, like, we need any other customs data set, because every time, like, I show an example, like, it might be like the case, like, I want to import any in already existing data set, like C14 and others, but we're using our very own data set. We don't need that. So from TensorFlow dot keras dot pre-processing dot image import image data generator, and also I don't want to write this again and again, so I'll just copy till this part. So from TensorFlow dot keras dot models, I'm gonna import sequential dot layers, import dense dropout activation, and also flatten. And maybe finally, from TensorFlow.keras.layers, import conv2d, max pulling 2d, max pulling 2d. I think, like, these kind of libraries are enough for the operations that I'm going to do next. So I'm gonna make sure that if I have done any kind of mistake, like spelling or capital or small, just to run this and see that if everything is fine. I think everything is fine. And import pickle. I think I don't have to do it again, but let's do, because we already have the extra pickle and wider pickle, but I'm just going to do it again in case, like, you wanna start it from the second half after finishing the first half in terms of importing the data. So import pickle. So pickle in is equal to open, so x dot pickle, and this time I'm going to read it. So last time it was like WB for writing back, this is reading back, RB. So pickle in open equal to open x dot pickle and then RB. X equals to pickle dot load, then pickle underscore in, and I'm going to do the same for the y. I'm too lazy to write the same codes again and again, and also it's getting really long tutorial. Pickle in and then y and then y. There are problems, so let's check it out again. Pickle in, pickle x pickle dot load pickle in, and then pickle in, open y dot pickle rb. Okay. So I check these things out again and again because I don't want to get into an embarrassing situation in front of you guys where that my codes are not running and I get into an error that I cannot fix myself. So I'm not going to do that. So I'm going to normalize also. Just run again. And then our next part. Model equals, oh shit, sequential, and then model dot add conv2d 256, 3, 3. So let's specify our input shape. So sometimes I really get confused with the parentheses here. Count to the 3, 3, and then I think I have to start from here. Input underscore shape equal x dot shape model dot add. I think I am going to give an activation layer here. Activation, and of course we're gonna use relu. And then I need one max pooling layer. Model dot add the max pooling 2D. So pool size is equal to 2, 2. I think we're gonna need another convolutional layer. Model dot add. I think I'm not going to write this again. I'm gonna copy. Oh, let's just write model dot add conv 2D 256, 3, 3. And I'm going to use one more activation layer. Just copy it from here and then paste. And then I think again I'm gonna need another max pooling layer. Copy and paste. And lastly, I need to convert my 3D features maps into 1D feature vectors. So to do that, model dot add, I'm going to use a flatten layer. Flatten. And then model dot dense, add dot dense. Add. This is a dense layer. Dense, and then finally I need one more activation layer, and this time I'm going to use the sigmoid. I need the value between kind of within 0 and 1. So activation is sigmoid this time for me. And the next stage is I want to compile my model. So model dot compile. So there can be many options that I can use. So let's use the loss is equal to binary cross entropy. We need codings. Loss is equal to binary cross entropy. And we need an optimizer. So optimizer, we're going to use the atom optimizer for this. Equals to atom. And there, let's use some metrics also. I can use many metrics like mean square or AUC, but for these I'm just going to limit myself to accuracy, because later I'm going to show you how to put the confusion matrix and get the F1 score and other things. So just for this case, let's just use the accuracy. And the last piece, so model.feed x comma y. So the batch size, let's specify our batch size is equal to 32, and we are gonna have 3 epochs. Free and for validation. So validation is split. For validation is split, I think let's how much? Oh, 0.3. Let's do it. Ooh, I'm kind of nervous. Like, I don't know. I'm kind of like very new to making tutorials, so I often end up making a lot of mistakes. So I'm also really nervous when I'm making the videos, and I'm not sure like if this is gonna run well, if we're going to have any mistake, and let's check it out again. If I don't want to get into any silly mistake here and check out everything once again. So if this runs, then I think our code is done, and definitely it's going to take some time to train. So I'm not sure if I'm going to continue the whole video even while training, but I think you guys would like to see the progress too. So let's run it. See, there is an error. So where is it? Model.add.com 2D. So what's wrong here? So this is kind of like they say that invalid syntax. So why? So model.add.conf2d. So I imported, right? But as Keras import conf2d, conv2d. So model.conf2d. Let's check out again. Okay, no worries, I'm gonna fix it. Just give me some time. Why is it being so nasty to me? Okay, so I think it works now. So I exactly don't know what happened here. I did everything right, but I just had to like take a piece of code like that I created earlier. Before making this tutorial, I ran all these codes to see if it's working or not. So I just copied this portion of the code from there and copied it here so that I don't have to, like, everything was perfect. Like, what was wrong? I didn't know actually. So maybe any uppercase or lowercase issues or spelling issues. No worries, but it's running. So we have 3 epochs, and like we have as you can see that at the very beginning the loss is very high and the accuracy is low. So as time passes by, so you will figure out like that the accuracy will increase more and the loss will decrease. But I think it's going to take some while to train it. And anyway, so what I'm going to do is like I'm going to show you the same thing, the same training issues, like how how the accuracy was from another piece of code that I did previously. So what I'm going to do is like I'm going to move to that. So here it is. Like, oh no, I can't do that because oh, I think I have to wait. It's because like I'm using Windows Game Bar, so if I switch to another tab or another application, so it's not going to show me. The application is locked into this Google Chrome only, this tab of the Google Chrome. So anyway, it's kind of like it's gonna go on and on again after 3 epochs, and the loss, as you can see, has decreased to 3.14 and now 3, and the accuracy has increased. So finally we'll receive up to like 90% accuracy here. So in the next video of mine, what I'm going to do is I'm going to show you how to have like how to plot the confusion matrix out of this neural network, and how to see the F1 score, how to see the precision, recall, and other scores. So anyway, like, thanks for staying with me, and I did mess up a little bit at the end of this video, like while compiling the model and everything. I hope as a new YouTuber you'll forgive me for that. Till then, goodbye.